असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय। ॐ शान्ति शान्ति शान्तिः।
Namaste Makale. In this video, we continue with types of velocities. So in the last video, I said about velocity, rate of displacement, and I explained many things there. Or in today's video, we learn, say, what are the types of velocities. In fact, first type is uniform velocity. First type is uniform velocity. Uniform velocity. What do you mean by that? Observe, we write a figure. Always, as I told you, we must get mental pictures. Pictures are very important. Once we know the pictures, once we listen to a particular word, if it creates a picture in our mind, definitely we are learning it. That's what we mean by understanding. Okay, now, uniform velocity, to understand this, we create a picture. Just observe, we are having a long road, a straight horizontal road. No ups and no downs, no brakes are applied, not like that. And observe, I mark the timings, lines on this road for the sake of understanding what is uniform velocity. Say, this is 0, 1 meter, I take or else we can take 30 kilometer, 60 kilometer, 90 kilometer, 120 kilometer, it goes like that. And in the 0 second, we imagine we are in a car. The car is at 0 kilometer mark. It is moving with 30 kilometers per hour without changing its speed, braking, without applying the brake or anything. In the next moment, say at t equals 0, it is here. At, say, this is at t equals 0. If I write another figure for t equals 1 hour, t equals 1 hour, after 1 hour, where it is, the car is exactly covered 30 kilometer like this. Next, after 1 more hour, t is in the second hour. Here to here 1 hour, here to here 1 hour. It is at 60 kilometers mark on the road. Likewise, if you want, I can write one more. T equals third hour. That means the car is somewhere here. Car is somewhere here. My car shapes are changing, nothing to worry. Say car is here. 90 kilometer. Observe what is the displacement here in the 0 to 1 hour, 30 kilometers from here to here. From 1 hour to 2 hours, 30 to 60, that is displacement 30 kilometers. From 2 hour to 3 hour, second hour to third hour, 60 to 90, the displacement is 30. That means every hour displacement is 30, 30, 30 in our example. That's what we mean by uniform velocity. Means, can you think of it for a while? If you want, you can stop this video at this point and create the answer for uniform velocity. Then you continue with the video. Observe, uniform velocity in 1 hour 30 kilometer, next hour 30 kilometer, next hour 30 kilometer. So displacement, 30 kilometer displacement in each hour, equal displacement. Instead of writing that equal displacement I write. In what? In equal intervals of time, 1 hour. In equal intervals of time, equal intervals of time. Here in our example, 1 hour. So this is what we mean by uniform velocity. Observe, I am using the word velocity, not the speed, because here direction is also not changing. It is continuously moving from left to right. Even though I have shown four figures here, each figure is on same road but different instants of time, t 1 hour, t 2 hour, t 3 hour, like that. Okay, so with that now, just observe. That is about uniform velocity here and after. Whenever you hear that word in your mind, it covers equal displacement in equal intervals of time. One such thing, picture should be in your mind. Now, second velocity is variable velocity. What is variable velocity? It is day to day life affair. Say you are moving on a car or you are moving on a two wheeler. Suddenly, your velocity is at 40 kilometers per hour. Suddenly, in the road, some a dog passes, you apply the brake till it comes to rest. So your velocity becomes zero. Next, you accelerate, but there is a traffic island. Red signal is there. You have to stop. From again, it increased velocity and then come to zero. That means each and every second, the velocity is the magnitude of velocity is changing. Not only that, direction may also change. In this moment, we are traveling in 40 kilometers per hour from north to south. Later on, we change to south towards west. So, but quantity, the magnitude 40 kilometers may say, but direction changed. In all these cases, we say variable velocity. But now observe one more thing, very important, instantaneous velocity. What does it mean? Just observe. You might have heard of instant coffee. Instant coffee, you have Nescafe instant coffee, Brew instant coffee, like that. So, what do you mean by that? You have a hot milk and you add sugar along with that instant coffee mixture and stir it and drink it instantaneously at that moment whenever you decide to drink the coffee. You need not wait for decoction to happen and all those things. That's what we call as instantaneous, instant coffee. In this case also, instantaneous, at that instant. Say you are in a car, you observe the car and also you have a compass box with you. Then car speedometer shows 40 kilometers per hour and your compass box, say your compass needle shows you are moving towards from north to south. Then your velocity is 40 kilometers per hour from north to south. So velocity is 40 kilometer per hour from north to south at this moment when you look at the meter. But in the next moment, the speedometer, a driver may accelerate the vehicle, speedometer may show in the next after few minutes 60 kilometers and direction your compass is showing same thing. Then you may write velocity now at that moment when you observe is 60 kilometer per hour from north to south. Also, not only north to south, it might have changed the direction also. Then also at that moment, velocity, direction as well as magnitude changing. These spikes are called as, these velocities are called as instantaneous. At that moment, nothing after or nothing before. So that's what we call as instantaneous velocity. In the next video, we'll come up with how to measure instantaneous velocity that was devised by Newton around 360 years back. And that is by a new mathematics what was designed by Newton and later on borrowed by the mathematician called as differential calculus. So we'll learn that in the next video. There I conclude this video for now.